The Châtelet site of ArcelorMittal is dedicated to the production of stainless steel and is equipped with both a melt shop and a rolling mill. Its steel plant stockyard has everything necessary for top quality stainless steel production. The process begins with recycled steel scrap and a set of additional elements called ferroalloys. Châtelet receives its raw materials by canal barge or rail and road truck. Upon delivery, the scrap metal is classified by size and composition and then separated accordingly into different holding bays. All the waste products from the site itself are also reused in the same way. The materials necessary for undertaking a melting charge are poured into big tanks called hoppers. The precise composition of the charge and the order of the layers of each hopper are varied according to the specification required by each client. Between the layers of scrap metal, chromium is poured into the hopper in specific quantities. Subsequently, nickel and other ferroalloys are added to the melt via conveyor belts. In each melt, 170 tons of scrap are charged in 2 stages, fed by 2 hoppers. The 3 electrodes of the furnace create an electric arc that melts the steel and ferroalloys, bringing the furnace melt temperature to around 1650 degrees Celsius. 80 minutes are on average necessary to carry out a cycle, including the charging, the fusion of the material, and the emptying of the furnace. From the transfer ladle, the molten steel alloy is poured into the AOD converter. AOD means argon oxygen decarburization. The oxygen and argon gases are blown from the bottom and top of the converter to purify the steel by removing the unwanted carbon. It is also at this stage that different alloys and chemical elements are incorporated after supplying them towards the AOD via conveyor belts. From the AOD converter, the molten steel is poured into a ladle, which is then transferred to one of 2 ladle metallurgy stands. Here, the composition of the metal mixture will get its final touches. The process can be compared to a kitchen chef preparing a fine dish. The chef adds seasoning, herbs and spices, and at the end, the metallurgist adds the elements which allow the stainless steel to be suitable for use as piping work, tanks, exhaust silencers, as cutlery or as cooking pans. Throughout the process, samples are systematically taken for analysis in the plant laboratory. This operation allows us to determine the ingredients that need to be added in order to accurately respect the client's specification. The operators of the ladle metallurgy stands also have a crucial role. Their task is to skillfully control the temperature of the steel. It must be ideal, within a few degree intervals, to properly cast the melt in the continuous caster. This bath shape at the intake of the continuous casting machine is called the tundish. This is where the steel is poured, fed by one of the 2 casting ladles that can be positioned in the casting turret. Their ability to hold 25 tons of melt permits the casting to continue without stopping the machine during the changeover from one ladle to the other. The melt is then poured into the copper mould, which is permanently cooled by lots of water to rapidly solidify the molten metal. Once the outer shell of the metal is solidified, it travels through a set of rolls that will gradually turn the casting direction from vertical to horizontal. Meanwhile, the cooling is continued until the metal strand is solid throughout its complete thickness. The solidified strand is cut out into pieces of maximum 12 meters in length and 20 centimeters in thickness. These pieces are called slabs. A final operation can be carried out in the melt shop. Grinding both the upper and lower faces of the slab eliminates surface imperfections. Each slab weighs between 20 and 30 tons, i.e. the weight of more than 20 cars. They are driven to the rolling mill by a very special truck capable of transporting 4 times more than a standard articulated trailer. Slabs from the Genk melt shop are also transported to the hot rolling mill of Châtelet by barge or by train. When it leaves the melt shop, each slab is given an identification number to ensure its traceability. Before being treated in the rolling mill, the slabs have to be reheated in one of 3 furnaces for about 3 hours. Each furnace can hold about 30 slabs, which come out as and when they are required, at a temperature of 1250 degrees Celsius. They will now be able to be rolled. Every 3 minutes, the table roller of the rolling mill brings the slab to the roughing mill. The steel goes 5 to 7 times through the roughing mill, alternately in one direction and then in another. Between each movement, the rollers get closer and closer together in order to press down the steel each time and make it thinner. At the end of the operation, the strip is only 32 mm in thickness, whereas it is 20 cm in thickness when it enters the rolling mill. The roughing mill also regulates the final width of the strip according to the client's requirement. After passing through the roughing mill, the temperature of the steel drops to 1100 degrees Celsius. Made up of 13 mobile panels equipped with burners supplied with natural gas, the thermal tunnel maintains the steel at this temperature until the next stage. The head and the tail strip are cut with a crop shear placed at the intake of the finishing mill. In the finishing mill, the work is done in a single continuous movement. The steel goes through 7 cages in which the rolls are gradually placed closer together. All the cages are controlled by computer, and the speed, which increases after each cage, is controlled automatically. By passing once through the 7 cages, the thickness of the strip can be reduced more than 20 times, and so thinned down to 1.5 millimeters. When the hot rolling work is completed, the original slab, 12 meters long, has turned into a strip of up to 2 kilometers long. This strip is taken up and rolled into a coil on one of the 2 coilers at the end of the line. The 2 coilers work alternately, following the production rhythm. The coils are marked and transferred towards the stockyard. They will then leave the Châtelet site by train or by barge towards the different cold rolling mills of ArcelorMittal, where they will be further transformed for delivery to final product manufacturers.